Hey folks, Ms. Gosling here. In this video, you're going to learn about types of energy. By the end of the video, you'll be able to describe different types of energy and to calculate some types of energy. So with that, let's go ahead and get started. So I'd like to start by discussing some of the different kinds of energy you will see in this class. So we have at the top left corner, nuclear energy, which is the energy stored in the nucleus of an atom, the energy that's kind of keeping that nucleus bound together. We have electrical energy, which is the energy due to the relative position of charges. We have light and heat, two forms of energy that are often found together. So you'll notice my pictures for light and heat both produce the other as well. So the sun produces both light and heat, as do light bulbs. We have elastic potential energy, which is the energy stored by stretching out a rubber band or a spring. So that's kind of the energy that results in that rubber band moving quickly once you release it. Another kind of potential energy is gravitational potential energy. So this is represented in this picture by the top of a hill on a roller coaster, because roller coasters really work through energy. So what's happening is as you go down the hill, you're speeding up because the gravitational potential energy of your height at the top of the hill is turning into another kind of energy, which we call kinetic energy, which is the energy of motion, so the energy you have because you're moving. The last kind of energy pictured here is the chemical potential energy, which is the energy stored due to the molecules inside of different objects. So for example, coal has chemical potential energy that could be burned to produce light and heat. Similarly, the food you eat has chemical energy, which can be used to make the bodily processes in your body work, and then also for you to move and run and walk and jump and all of that fun stuff. So because there's a lot of different kinds of energy, it can be useful to categorize our energy as what I like to call kinetic versus potential, or used energy versus stored energy. So on the left, we have our stored energy, so our potential energies. So we have that nuclear potential, the electrical potential. We have our chemical potential, gravitational potential, and elastic potential. Whereas on the right, we have energy that's being used. So we have light and heat and movement, which are those things that we kind of take our potential energy, our stored energy, and turn it into light or heat or movement. Now, I really want to jump in and kind of zoom in on two specific kinds of energy that we're going to be focusing on in this class. The first is kinetic energy, which again is the energy of motion. And we're going to use the letter K to represent kinetic energy. And we're going to go ahead and measure our kinetic energy in joules. So it's measured in joules, which we represent with a capital letter J. And our kinetic energy is defined as being half the mass of an object in kilograms times its speed squared. And of course, our speed is going to be in meters per second. Now you'll notice I said speed instead of velocity, and that is because when we calculate our kinetic potential energy, we are squaring our speed. And so when we represent our direction as a negative sign, so for example, to the left is -2, while to the right is +2, -2 squared is equal to +2 squared, since they're both going to be equal to 4. So when we calculate our kinetic energy, our direction is going to disappear. So again, the key thing for you to know here then is that energy is a scalar quantity, so we don't have to worry about directions, which I'm sure you guys will be very happy about. So here's an example. An electron has a mass of 9.1 times 10 to the -31st kilograms and travels at 2.2 times 10 to the 6th meters per second around a hydrogen nucleus. What is its kinetic energy? So let's go ahead and go through the guess method. So we know that the mass of the electron is 9.1 times 10 to the 31st kilograms, and that its speed v is 2.2 times 10 to the 6th meters per second. You'll notice I represent it a little bit differently here. Just remember, ms to the -1 is the same thing as saying meters per second. So moving on, I want to find my unknown. And what I will find is that my unknown is my kinetic energy, since that is what the question is asking me to find. Which brings me to my equation. So I know that kinetic energy is given by 1/2 times my mass times my speed squared. And now that I have my equation, I can go ahead and sub and solve. And I am going to mention, guys, make sure you add your equation to an equation sheet. That will make finding equations much easier for you as you move forward. Anywho, subbing and solving, I find that my kinetic energy is equal to 1/2 times my mass, so 9.1 times 10 to the 31st, times my speed squared, which is 2.2 times 10 to the 6th, and we're squaring that whole thing. So you'll notice I put my exponent outside of my parentheses because I need to square 2.2, but I also need to square 10 to the 6th. Since remember, this is scientific notation for 2, 2, and then 5 zeros. So 2,200,000. So I'm squaring that whole thing, not just the 10 to the 6th or just the 2.2. And when I put it in the calculator, what I should get is that my kinetic energy is equal to 2.2 times 10 to the -19th joules. So there you go. That is one example of how we calculate kinetic energy. Now let's take a look at a second type of energy, and that is our gravitational potential energy. We're going to represent, and remember that is our energy stored due to our position relative to the ground. Or whatever we define as our zero. And when I say other 0 point, what I mean is that if I'm dropping an object from onto a table instead of onto the ground, then I probably want to say the table is where I have 0 potential energy versus the ground, because the ground isn't really relevant in that situation. So with that, we're going to use the symbol U sub G, or just U, to represent gravitational potential energy. And so again, that's our gravitational potential energy, which I'll sometimes represent with just PE. We're going to also measure that in joules. And like kinetic energy, potential energy is a scalar. Now, our potential energy is given by mass, again in kilograms, times little g, which is 9.8 on Earth. Might be different if we're on a different planet. Times our height off the ground, which we're going to measure in meters. So that is our equation for gravitational potential energy. Let's go ahead and look at an example. So example 2. Al holds a 10 Newton apple 2 meters above Isaac's head. What is its potential energy relative to Isaac? So let's go ahead and start by drawing a picture here. So here is my apple, which has a weight of 10 newtons and is 2 meters above Isaac's head. And what I'm going to say is that Isaac's head is where my height is 0. So my height for this problem then will be 2 meters. And I know that that's going to be my 0 point because I'm asking relative to Isaac. Another way that you might know is if it said what's its potential energy if it's going to fall into Isaac's head. You can also just assume it because that's the height that we know. So generally when you get these problems, your instinct as to what the height is usually right. So with that, let's go ahead and go through our givens. So we know that our weight is 10 newtons. And we also know, remember, weight is equal to mass times little g. So what that means is that mg is equal to 10. So I'm going to go ahead and just condense that down into one line. So my weight is equal to mg, which is 10. My weight is 10 newtons, and my weight is mg. So mg is 10 newtons. I also know that my height is 2 meters. And I am trying to find my gravitational potential energy, U sub g. So that brings me to my equation. So I know that my gravitational potential energy is equal to mgh. I also know that mg is equal to my weight. So one thing that we can see here, guys, is that another way to write my gravitational potential energy is weight times height, or the force of gravity times my height. Now, regardless of what we choose, we know that my weight, or my force of gravity, is 10 newtons. So let's go ahead and start subbing. And solving. So I know that UG is equal to my weight times my height, or MGH. Therefore, my gravitational potential energy is 10 times 2, or 20 joules. And there you have it, folks. Here is my solution to our second example problem. So let's go ahead and talk takeaways. First, there are many different types of energy. And one way we can categorize energy is by calling it, and I'm gonna cross off kinetic and potential, and I'm gonna say as either used energy or stored energy. And we can calculate our kinetic energy and our gravitational potential energy using the equations 1/2 mv squared is equal to k, and ug is equal to mgh. So there you have it, folks. It is now your turn to try doing some energy calculations. Best of luck and happy solving.